In this video, I hope to show how we can derive the quadratic formula by completing the square. Here's our standard form of a quadratic equation. ax squared plus bx plus c equals 0. When we're completing the square, the first step is to divide by our value a, divide by that coefficient, dividing by a in each position. Well, a divided by a will leave us x squared. b over a, we'll write that as the fraction b divided by a times x. C over a is a constant, we'll leave as c over a. Well, 0 divided anything is 0. Alright. Step 2, we're going to gather our x terms on the left and put our constant term on the right. So this would become x squared plus b over ax is equal to, subtracting c divided by a from both sides will look like minus c over a. From this step to this step, I've simply subtracted this c over a on both sides, leaving 0 here. 0 minus c over a is a negative c over a. Alright, I want to add in my box number, which will make my trinomial on the left a perfect square trinomial. So, x squared plus b divided by a times x. So now adding in my box number. Box on the left, minus c over a, box on the right. What goes in the box? Well, it's half of this number squared. So, my box, I'm going to take b over a, and I'm going to take half of that. Well, half of b over a is b over 2a. To take half of a number, you simply double the denominator. Well, to square that would be b squared over 4a squared. b times b is b squared. 2a times 2a is 4a squared. Again, the box is 1/2 of the coefficient of x squared. Half of b over a is b over 2a. Squaring b squared over 4a squared. So that is my box number. b squared divided by 4a squared. b squared over 4a squared. Alright, now we can write this left side as one binomial squared. The square root of x squared is x. The square root of b squared over 4a squared is b over 2a. This operator goes in between. And again, this term is also 1/2 of this one. Half of b over a is b over 2a. Quantity squared. Alright, well, I want to add these two quantities together. To add together fractions, you need a common denominator. Well, this one has an a, this one has a 4a squared. To get a common denominator, I need this to look like 4a squared. What do I need to multiply by? I need to multiply by 4a. Whatever I multiply by the top, by the bottom, I multiply by the top. I'm just finding a common denominator. So I haven't changed this value. I've just multiplied by 4a over 4a, which is 1. All I'm doing here is finding a common denominator. So in the top, I have negative c times 4a. That's negative 4ac is another way to write that. 4a times c, but negative. 4ac negative. In the bottom, I have 4 and 2a's, that's 4a squared. I did that so I could add these two fractions together. Alright, since I have this common denominator, I can write it over 1. Since the denominators are common, I can now combine, or I can now add these numerators. This is negative 4ac plus b squared. Said another way, it's b squared minus 4ac. Well, I hope you can already see that we have some quadratic formula type features. This is our discriminant, this b squared minus 4ac. Alright, so now I have the statement x plus b over 2a quantity squared is equal to this fraction, b squared minus 4ac, all divided by 4a squared. Now I will take the square root of both sides. Square root of x plus b over 2a quantity squared. Well, the square root would just cancel the squared. It will come out. This binomial comes out, x plus b over 2a. And to take the square root of this? Well, the square root of a fraction, b squared minus 4ac all over 4a squared is equal to the square root of the top, b squared minus 4ac, over the square root of the bottom, square root of 4a squared. Well, we can easily take the square root of 4a squared. It's 2a. Square root of 4 is 2, square root of a squared is a. And I'm going to leave this numerator as the square root of b squared minus 4ac. And remember, we need to consider both the positive and the negative. You may be thinking, why didn't you write that positive and negative in every position we took the square root? We certainly could have. But what we would end up with are a lot of positive and negatives that will end up giving us some duplicate answers. It's sufficient to write it in this one position. So x plus b divided by 2a is equal to this statement, both the positive and negative square root of b squared minus 4ac all divided by 2a. All right, I want to solve for x. I will subtract this term here, this b minus 2a on both sides, subtracting, b over 2a. Subtract b over 2a. So this yields x equals negative b over 2a, negative b over 2a, plus and minus the square root of b squared minus 4ac all divided by 2a. Well, once again, we have this common denominator, this 2a in the bottom, so I can write these two fractions as one fraction. X is equal to, the denominator is 2a. In the numerator, we have negative b, plus and minus this radical expression. And that is the quadratic formula. So what we see is the quadratic formula is simply just a sterilized version of completing the square. So if we know how to complete the square, if we know how to do this process, we don't need the quadratic formula. Completing the square will always solve any quadratic. Okay. We don't need the quadratic formula. Now, having said that, if you really like the quadratic formula and you feel like it's an easy way to get there, that's fantastic. Use the quadratic formula. But completing the square will get that done. And completing the square has more utility for us beyond simply solving a quadratic equation. We've already seen completing the square to get our vertex form. And there will be later on in math, we have a long list of things that completing the square will allow you to do. While quadratic formula is just a stripped down version of that will allow us to find the solutions of a quadratic equation.